On behalf of 24HourAnswers.com, I welcome you to today's lesson. In this video, we're going to look at another example of using the quotient rule and the chain rule together. Here we have v of t equals this rational function inside of here, and it's all raised to the third power. In a previous video, we did look at another example of the quotient rule and chain rule together, where we were doing the quotient rule and we applied the chain rule down here in this denominator. The problem we're going to work on now is a little bit different, because now we have this function here sitting inside of this stuff that's getting cubed. So we have some stuff getting cubed. And recall, if we had y equals u to the third power, the shorthand way of showing chain rule here is y prime equals 3u squared du. So really what we're doing here is we're applying the derivative u cubed. We're pulling the 3 down, we subtract 1 from our exponent, and then we come back and we multiply by the derivative of that u. So let's call this stuff right here ru. Therefore, v prime of t is going to be equal to. Now, when I say u, I'm referring to everything that's inside of here, all this stuff getting cubed. Therefore, v prime of t, we pull that 3 down, we leave that u alone for right now, just like over here, 3u squared. Let's not forget our squared, because that 3 we subtract 1 from it. And then we have to come back and multiply by the derivative of that stuff that we left alone. This is where we have to apply the quotient rule. So doing that here, we're going to take low d high minus high d low all over low low. So therefore we have low d high, that's going to be 8t cubed, minus high, leave that alone now, 2t to the fourth, d low, that's going to be 1 over t, because the derivative of natural log is 1 over t, and then this is all over low low, so natural log of t squared. Now let's work on cleaning this up a little bit. We can at least combine all of this stuff together to make it one cohesive fraction, I guess you could say. So what we could do here is we could take this 3 multiply it by 2t to the fourth squared. That's going to be 4t to the eighth, because t to the fourth squared is t to the eighth. 2 squared is 4, times that 3 gives us 12t to the eighth over natural log of t squared. So again, what I did there is I squared the 2, I got 4. I multiplied by that 3, I got 12. T to the fourth squared gives us t to the eighth, and let's not forget to square our denominator as well. Multiplying that by this stuff over here, just going to clean this up a little bit, 8t cubed natural log of t minus, now here we can get rid of one of these t's because this is 2t to the fourth times 1, which is still going to give us 2t to the fourth, all over t, that gives us 2t cubed. All I did there was subtract 1 from the exponent of t to the fourth, and this is all over the natural log of t all squared. Now ironically, we have common denominators, which we don't need those because we're multiplying these two fractions, but we can factor. If you look at all the stuff that we have here, now if I were to multiply this stuff times this stuff over here, you know, that's really what's going on. It's like a big old distributive property for these two terms that we have inside of this parentheses. But I'm not going to distribute. I'm going to factor, and then I'm going to have a natural log of t to the fourth power in the denominator, since we're multiplying fractions. We take top times top, bottom times bottom. But I'm going to work on cleaning this up by factoring. So therefore, let's factor a 2 out of both of these terms. We already have a 12 out here, so that's going to give us 24. And let's also factor out the t cubed that we have here, because both of these terms have a t cubed in it. Notice we already have t to the 8th out here, so that's going to be t to the 11th power. All I'm doing there is factoring that out, and I'm adding it on to that exponent there. That leaves us with, we factored a 2 out, so we have 4 natural log of t, since we did not factor out the natural log of t. And again, notice that t cubed is gone now because we factored it out. Now we did factor out a 2t cubed, so that's exactly what we have here. Don't forget though, that is minus 1. And then this is going to be all over, as I mentioned earlier, the natural log of t all to the fourth power. Now, when are you actually going to be using something like this in calculus for like a real world application? Probably never. Again, this is one of those exercises here where you want to exercise your ability to find derivatives, in this case applying the quotient rule and the chain rule together. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.